Hi everyone, today we're going to talk about the area of a triangle. And what you already know is the area of a triangle is 1/2 base times height. So if I give you this triangle right here, triangle A, B, C, and I make a height, so I'm going to drop down a perpendicular here, and I'm going to say that this base is 10 or 10 inches. And I'm going to say the height is 4 inches. So how would I find the area? The area would be 1/2 base height. Now this here can't be a height because height has to be measured from top to bottom, something that's perpendicular to the base to measure height. So again, the area would be 1/2 times 10 times 4. If you put that into the calculator, you would get 20. An area is always measured in units squared. So if I don't have units, just put units squared. This is easy. This you should remember from 6th grade. So what we're going to need to do now is do the area of a triangle when I don't have a perpendicular height. There's a trig formula, and the formula is given to you on the reference sheet. You don't have to memorize it. It's K equals 1/2 AB sine C. So it's the first formula on the reference sheet, and what it stands for, K is the area, A and B are two sides, and C is the included angle. What do I mean by included angle? So here, if I look in the diagram to the right, I could say A is here, B is here, and sine of C. Well, where's angle C? Angle C is here. So this situation is I have a side, I have an angle, and a side. So if you have side, angle, side, you can use the area of a triangle formula. Now, if they had given you sides A and C, they would need to give you angle B in order for you to use that for the area formula. So it has to be the included angle of the two given sides. So let's try example number 1. Given the triangle below, find its area. So there's no perpendicular height, so we're going to use K equals 1/2 AB sine C. Now the A and the B are unnecessary. It doesn't necessarily have to be side A, even though this is side A. It doesn't necessarily have to be side B. It could be whatever. As long as you have side, angle, side, you're good to go. So let's plug in what I have. K equals 1/2. A is one of the sides. Let's pick 12. B is one of the sides, 18. Sine of C, C is 94. So you're just going to plug that into the calculator just the way you see it, and you should get 107.737 units squared. Pause the video, check it out, see if you can get that. Alright, that's it. Let's try example number 2. Given the parallelogram below, find its area to the nearest tenth. Well, do you agree that a parallelogram, this parallelogram, is made up of two equal triangles? Well, that would mean that then this triangle down here would be equal to this triangle up here. So if I find the area of one of them, I could just multiply it by 2. So do I have side, angle, side? Side, angle, side. So let's find the area. K equals 1/2 AB sine C. So remember, A and B are just the two included sides, and C is the angle between them. So K equals 1/2, two sides, 10 and 16, sine of 60. So K equals, take a minute, plug this whole thing to the calculator, and get me a number. That number should be 69.2820 ... But that's the area for one of the triangles, and a parallelogram is made up of two triangles that are the same, so I just multiply that by 2, so hit times 2 in the calculator, and you should get 138.6 units squared. It says round to the nearest tenth, so I rounded it to 1 decimal place. Okay, is there a shortcut? Is there a formula that I could use for a parallelogram instead of finding the area of one triangle and then multiplying it by 2? Well, let's examine the area formula for a triangle. And what am I going to do with this triangle formula to find a parallelogram? Well, what did we do here? We used the triangle formula, multiplied it by 2 to get the area of a parallelogram. So if I take this formula as is, this 1/2 AB sine C for one triangle, multiply it by 2, what can cancel? See how this 2 and that 2 can cancel? So really the area of a parallelogram is just AB sine C. So this would be for a parallelogram. So all you need to do is just kind of get rid of that half in front, because when you take a half and multiply by 2, you just get 1 in front. And that's it. So if you want, try AB, so try 10 times 16 sine of 60 degrees. So in the calculator, try A would be 10, B would be 16, sine of the angle, which is 60. If you put this into the calculator, you will get that. All right, let's go to the next page. Okay, question 3 involves an isosceles triangle. I just want to review what isosceles means. Isosceles means that you have 2 equal sides and 2 equal angles. So let's just draw a triangle and label its parts. If I have a triangle that's isosceles, I'm going to say these 2 sides are equal. And this angle up top is called the vertex angle. And these angles down here, both of them, are called base angles because they're on the bottom. So this is a base angle as well. And the base angles in an isosceles triangle are equal. So if these 2 sides are equal, the sides opposite, the angles opposite are also congruent. So that would mean this angle in here is equal to that angle in there. Okay, so now let's read the problem. In triangle ABC, so let's draw triangle ABC. Base angle C is 30. So if 30 is a base angle, the other base angle, A, would have to be 30 because they're equal. And the measure of angle C is 10. Find the exact area of the triangle. So the exact area, you should be thinking exact value chart. So we might need that. So let's write down the formula first. K equals 1/2 AB sine C. So the A and the B, again, doesn't matter just as long as you have side, angle, side. Well, right now it seems as though as I only have one side. Well, I know that if these 2 angles are equal, the sides opposite those have to be equal if it's isosceles. So those 2 would have to be 10. So here is my side, here is my angle, here is my side. So I have side, angle, side. So the included angle for this problem is A. How do I find A? Well, I already have 30 and 30, which makes 60. So this angle up here would be 180 minus 60, which is 120. So that's the angle we're going to use. So 1/2, 10 times 10, sine of 120. But they're asking for the exact value. So that means you need to have those radicals in there. You need to somehow get it to be 30, 45, or 60. So what we can do is we can do quarters or sodas for this little piece right here. So what quadrant are we in? Quadrant 2. How do I find a reference angle in quadrant 2? You should be thinking 180 minus 120, which is 60. What function are we using? Sine. And S stands for sine. Is sine positive or negative in quadrant 2? It's positive. So this sine of 120 is the same thing as saying sine of 60. So sine 60. And if you want, you can multiply this. 1/2 times 10 times 10 is simply 50. So we're going to do 50 times sine of 60. Sine of 60, if you want to draw yourself a nice exact value chart, is rad 3 over 2. And we need to multiply that by 50. So we can divide this 50 and 2, and we'll get 25. So the answer would be 25 rad 3 units squared. I just don't have room to write units squared. That would be my exact area. Okay, example number 4. The adjacent sides of a parallelogram. So let's draw a parallelogram. Try parallelogram A, B, C, D. Adjacent just means sides next to each other are 12 and 15. I always like to label them around. The measure of one angle of the parallelogram is 135. How about we use 135 and label it as the obtuse angle, which it is. And just out of curiosity, what's this angle in here? You should be telling me 180 minus 135, because this angle and this angle are supplementary, and you get 45. Now, it won't matter if you put the diagonal this way and use the 12, the 45, and the 15, or if you put the diagonal this way and use the 12, the 15, and the 135. Either way, you'll still get the right answer. Let's use, for argument's sake, the one with the 45, because that makes life a lot easier, because then I don't have to do quarters or firstotas to find the exact area with this 135. So we're going to isolate our attention on this one right here. So the area of a parallelogram is going to be AB sine C. Notice how I got rid of the half, because it's going to be double. Double 1/2 is 1, so that goes away. So K equals, we'll use this as the two sides, 12 and 15, and we're going to use sine of 45. Now the reason why this works out is because sine of 45 and sine of 135 are the same thing. If you don't believe me, put in the calculator. Put in sine of 45 and put in sine of 135. Guarantee you they'll both be the same answer. So I chose the 45 because then I didn't have to do quarters or firstotas. If I did quarters or firstotas, I would get the 45. So it's just easier. And again, since they want the exact value, I would do sine of 45 is rad 2 over 2. And 12 times 15 is 180. And I can divide the 180 in 2, and I'll get 90. So 90 radical 2 units squared. All right, that's it. See you tomorrow.